Welcome to the V.Teach. The continuation of the series of the lecture. The content, another content is unit step function or Heaviside expansion. That is Heaviside unit function. The unit function is to be denoted by u of t minus a or h of t minus a, and it is to be defined as u of t minus a is equal to 0 if t less than a and 1 if t greater than or equal to a. So this is the graph of this unit step function. Now the Laplace transform of this unit step function, because this is very important for the 5 marks or the 2 marks, and also in the gate point of view this content is to be very important for you. Laplace transform of u of t minus a. So by the definition of the Laplace transform, integral 0 to infinity e power minus st into u of t minus a into dt. So that means this is the step function step at a. That is why I have to split this integral into the two parts, that is integral of 0 to a e power minus st into dt and a to infinity e power minus st into dt. So in between the limits of 0 to a, that is t less than a, the function is to be defined as to be 0. That is why I have to take it as to be 0. And also, so t greater than a, the function is to be 1, that is equal to, so take this value is to be 0 automatically. So now integral of a to infinity e power minus st into dt. Take the upper and lower bounds, that is e power minus st integration is e power minus st by minus s, limits a to infinity. Take the upper and lower bounds, that is equal to minus of 1 by s into e power minus infinity minus e power minus as, because we can replace t by a. Then automatically you may be getting off this value is e power minus infinity is 0. So that is equal to 1 by minus of minus plus 1 by s into e power minus s. Well, if you catch my point, this is the Laplace transform of the unit step function or impulse function. In some of the textbooks that may be given the name of this impulse function also. So this is important for the 5 marks. Okay, for the university examinations, and also in the gate point of view this content is to be very important, because the options are to be given like that in gate point of view. That is a option is 1 by s into e power minus as, and b option is 1 by s minus 1 into e power minus a into s minus 1, and option c is 1 by s plus 1 into e power minus of a into s plus 1, and option d is to be none of those. Like that the problems are to be asking in the gate examination. Now coming to the next content is second shifting theorem. This is also very important for you for the university examination point of view. So second shifting theorem. If L of f of t is equal to f power of s and g of t is equal to f of t minus a if t greater than a, then L of g of t is equal to Laplace transform of g of t is equal to e power minus as into f power of s. So the same content are also we have to apply here for getting of this result. Then automatically you may be remember the formula e power minus as into f power of s. Clarification point. So by using of this step function I have to apply here, that is a unit step function or the Heaviside unit function. So like that you may be getting of this result. Now, so this is the applications of the second shifting theorem. These problems are also to be important. Find the Laplace transform of g of t, where g of t is equal to cos of t minus pi by 3 if t greater than pi by 3, 0 if t less than pi by 3. So whenever you have to apply the second shifting theorem, you can assume the function f of t as to be cos t, and taking the L on both sides, L of f of t is equal to L of cos t. L of cos t means that is s by s square plus 1. By second shifting theorem, so this is equal to L of g of t is equal to e power minus as into f power of s, where a is equal to pi by 3. That is equal to L of g of t is equal to e power minus pi s by 3 into f power of s means this is s by s square plus 1. Simply have to write it here. Therefore, the Laplace transform of the given function by using of the second shifting theorem, so that is equal to, so s into e power minus pi s by 3 by s square plus 1. Now, so the next problem is to be similar to the impulse function or the unit step function. So t minus 2 whole cube into u of t minus 2. So we can choose the function f of t is equal to t cube other than that of the impulse function, that is equal to f of t is equal to t cube. Taking the Laplace transform on both sides, L of f of t is equal to L of t cube, that is to be very familiar to you. L of t power n means n factorial by s power n plus 1, that is equal to 3 factorial by s power 4, that is equal to f power of s we have to assume. Now the second shifting theorem, So that is equal to L of t minus a whole cube into nu of t minus a is equal to e power minus as into f power of s. Simply we can replace a by 2 because we have to find the impulse function of t minus 2 in place of that is a by 2, that is equal to t minus 2 whole cube into nu of t minus 2, that is equal to e power minus 2s into f power of s means that is 6 by s to the power of 4. Simply have to replace this one, that may be getting of this result. So these are the applications of the second shifting theorem. Now we can find, I will give some of the problem as to be work, whatever the content you have to learn the second shifting theorem can apply in that similar way. While doing of this problem, we have to assume the function as f of t is equal to sin t only. Taking the Laplace transform on both sides, that means L of f of t is equal to L of sin t. That means L of f of t means that is equal to f power of s is equal to 1 by s square plus 1. This is the f power of s value. Now we can apply the second shifting theorem, that is L of g of t is equal to e power minus as into f power of s. Simply you have to replace, that is a is equal to pi by 3, a is equal to 2 pi by 3, that is equal to e power minus of 2 pi s by 3 into f power of s means 1 by s square plus 1. So all of you catch my point? Now coming to the second content, that is change of scale property. So if L of f of t is equal to f power of s, then L of f of a t is equal to 1 by a into f power of s by a. So this property is called as change of scale property. Now, so please all of you this using, so find the Laplace transform of sin square of a t using change of scale property. This is called it as COSP, means that is change of scale property. First of all, so the function whatever you have to assume, that is f of t is equal to that is sin square t. How we can convert in terms of the cos a t, that is 1 minus of cos 2t by 2. Taking L on both sides, that is L of f of t is equal to L of 1 minus cos 2t by 2. Bring, I can apply the linearity property here, bring 1 by 2 into in front of the L, 1 by 2 into, so 1 by s minus s by s square plus 4. Taking the simplification, I had to assume this one has to be f power of s. Now, by change of scale property, what is that content? F of a t is equal to 1 by a into f power of s by a. Therefore, so by change of scale property, L of f of a t is equal to, so that is 1 by a into f power of s by a. Simply you can replace it as to be s by s by a. Okay, na? Here this is whatever the same technique you have to apply in the first shifting theorem. Here also you can apply the same technique, s by s by a. That is equal to 1 by a into f power of s value is this one, 2 by s into s square plus 4, changing s by s by a. Simply that may be getting of 1 by a into 2 by s by a into s square by a square plus 4. That means the Laplace transform of sin square a t is equal to 2 into a square by s into s square plus 4 a square. This is the simplification. Now, this is also very important problem. If L of f of t is equal to 9s square minus 12s plus 15 by s minus 1 whole cube. Okay, na? Simply, so this is the function, whatever the function, there is no bother about that. So this is the Laplace transform of some function only. So find the Laplace transform of f of 3t. So this is equal to L of f of t is equal to 9s square minus 12s plus 15 by s minus 1 whole cube. Had to apply the change of scale property. By change of scale property, f of a t, L of f of a t is equal to 1 by a into f power of s by a. Simply you can replace as here a means that is 3, that is put a equal to 3, that is equal to 1 by 3 into L of f of 3t is equal to 1 by 3 into 9s square minus 12s plus 15 by, so s minus 1 whole cube. Here I have to replace or changing s by 3, because this is the change of scale property. Whatever the exponential function is to be given in the problem, you can apply the first shifting theorem. Therefore, simply have to replace s by 3 only. S by 3 whole square minus 12 into s by 3 plus 15 by s by 3 minus 1 whole cube. Now, after simplification, that may be getting of 9 into s square minus 4s plus 15 by s minus 3 whole cube. In that similar way, if L of f of t is equal to 1 by s into e power minus 1 by s, then prove that the Laplace transform of e power minus t into f of 3t is equal to e power minus 3 by s plus 1 by s plus 1. Please all of you observe this. here you can apply the two methods simultaneously because the exponential function is to be given in the problem. That means we can apply the first shifting theorem, and also f of 3t is to be available, then only can apply the change of scale property. So here the problem is to be given L of f of t is equal to e power minus 1 by s by s. This is no bother about the function because the f bar of s value is to be given in the problem. Now, first of all, the change of scale property had to apply. By change of scale property, L of f of 3t is equal to 1 by 3 into f bar of s by 3. So, whatever the s value is to be available here, you can replace s by 3. That means that is equal to 1 by 3 into e power. So, that is 1 by s means that is 3 by s by s into 3. Then, after simplification, that may be getting off e power minus 3 by s by s. Now, again the function is to be available here e power minus t. E power minus t means that is nothing but of the first shifting theorem. So, that may be applied here. By first shifting theorem in L of e power minus t into f of 3t is equal to e power minus 3 by s by s, changing s by s plus 1. Because here I have to apply the first shifting theorem. That means you can take it as to be s by s plus 1. So, that is equal to minus of t is to be available. Therefore, we have to replace s by s plus 1. That is equal to minus of 3 by e power minus 3 by s plus 1 by s plus 1.